At first glance, Lake Taupo doesn't look dangerous at all. Blue water stretching across the center of New Zealand's North Island, fishing boats drifting quietly across the surface, tourists taking photos along the shoreline, families kayaking over water so peaceful it almost feels frozen in time. Honestly, if nobody told you what sat underneath that lake, you'd never suspect anything unusual. But beneath Lake Taupo lies one of the most dangerous volcanic systems on Earth, a supervolcano. And lately, scientists have started watching it more carefully again, because the ground around the lake has been moving, not dramatically enough for tourists to notice, but instruments noticed. The lake floor in some areas has been rising. Small earthquake swarms have increased beneath the region, hundreds of tiny tremors rattling underground rock deep beneath the water, most of them too weak for people to feel. But together, they tell scientists something uncomfortable. The volcanic system underneath Taupo is still active. That's the strange thing about supervolcanoes. People imagine giant explosions happening once, then ending forever. But supervolcanoes don't really die. They breathe, they shift, they deform the Earth slowly over time while magma and heat continue moving underground for thousands of years. And Taupo has a terrifying history. Roughly 1,800 years ago, this volcanic system produced one of the most violent eruptions in human history. Not New Zealand history, human history. The eruption was so powerful that ash spread across huge parts of the region. Pyroclastic flows tore across the landscape at incredible speeds. Entire forests vanished beneath volcanic devastation. Some researchers believe the sky may have darkened unusually far from the eruption itself. And the most disturbing part? Geologically speaking, that eruption wasn't even very long ago. That's why scientists pay such close attention to Taupo today, because the volcano beneath the lake never fully went quiet. Heat still rises from underground. Earthquakes still happen regularly. Hydrothermal systems still pulse beneath the region. And now parts of the lake itself are deforming again. That detail matters, because ground deformation often means pressure changes underground. But sometimes it means magma or volcanic fluids are moving beneath the surface. That's why volcanologists monitor Taupo so intensely. Not because they think a giant eruption is about to happen tomorrow, but because supervolcanoes are unpredictable on human timescales. Long, quiet periods can create a false sense of permanence. Then the Earth starts moving again. And honestly, that may be the most unsettling part about Lake Taupo. Everything above the surface still feels normal. People still swim there, still fish there, still build homes along the shoreline. Meanwhile, below the lake floor, one of Earth's largest volcanic systems continues shifting silently underground, and scientists are beginning to notice signs that the system may be heating up again. Lake Taupo exists because of catastrophe. That's the first thing people need to understand. The lake isn't sitting near the volcano. The lake is the volcano. Everything around Taupo was shaped by eruptions so violent, they permanently changed the landscape of New Zealand. And honestly, calling Taupo a volcano almost feels misleading because people imagine volcanoes as mountains, cone-shaped peaks, crater at the top, smoke rising dramatically into the sky. Taupo doesn't really work like that. Supervolcanoes are different. The dangerous part is usually hidden underground. Massive magma systems buried beneath the surface capable of storing unbelievable amounts of molten rock and gas over long periods of time. And when those systems erupt at full scale, the Earth itself can partially collapse inward. That collapse forms gigantic depressions called calderas. Lake Taupo sits inside one of those calderas, which means the peaceful lake tourists see today was created by ancient volcanic destruction on a scale almost impossible to visualize. The most famous eruption from Taupo happened around 232 CE. Scientists often call it the Hatepe eruption, and even by volcanic standards, it was extreme. Some researchers believe it may have been one of the most violent eruptions Earth experienced within the last several thousand years. Pyroclastic flows exploded outward across the landscape at hundreds of miles per hour. Superheated clouds of ash, gas, and volcanic debris erased forests almost instantly. Rivers changed course. Entire ecosystems vanished beneath ash and burning material. And the eruption column blasted deep into the atmosphere. That's the terrifying thing about supervolcano-scale eruptions. They don't just damage nearby regions. They can alter climate systems, air travel, sunlight, agriculture, and global weather patterns far beyond the eruption zone itself. Taupo's ancient eruption was so powerful that geological evidence of its ash appears across enormous areas of New Zealand. Some volcanic deposits remain dozens of meters thick. Think about that for a second. An explosion powerful enough to bury landscapes beneath layers of volcanic debris thicker than buildings. And yet the strangest part is this. Most people outside geology have barely heard of Taupo. That's probably because New Zealand feels remote to much of the world. Not like a place hiding one of Earth's largest volcanic systems underneath a lake. But scientists know exactly how serious Taupo is. That's why the region is monitored constantly. Because while the giant eruption happened long ago by human standards, geologically, the system is still alive. The heat beneath Taupo never disappeared. Hot fluids still circulate underground. Hydrothermal vents still release energy through the region. Earthquakes still fracture rock beneath the lake. And magma likely still exists deep below the Caldera system. That's what makes supervolcanoes psychologically unsettling. They spend most of their existence appearing quiet, calm enough for civilizations to grow on top of them, calm enough for humans to emotionally forget what happened there before. Then the ground starts moving again. And Taupo has definitely been moving. Researchers tracking the region detected periods of uplift and subsidence around the lake basin over recent years. Some shorelines shifted slightly upward, while nearby areas dropped. That pattern suggests pressure changes underneath the caldera. Now, pressure changes do not automatically mean a catastrophic eruption is coming. That's important. Volcanic systems naturally expand and contract over time, but deformation means the system is active, still dynamic, still evolving underground. And when earthquake swarms started increasing around parts of the lake, scientists paid even closer attention. Because earthquakes are often how volcanoes communicate movement underground. Rock fractures, fluids shift, pressure redistributes. The earth reacts physically to whatever is happening below. Most of the recent earthquakes near Taupo have been relatively small, tiny compared to major tectonic earthquakes. But frequency matters, especially inside active volcanic regions. And honestly, the lake itself makes the situation feel even stranger psychologically. Because water hides instability incredibly well. People stand along the shoreline looking at a calm blue lake without realizing the entire basin exists because of one of the most violent eruptions humans have ever witnessed. The silence above the water creates a false sense of permanence. But beneath Lake Taupo tonight, heat still moves through the crust of New Zealand. The volcanic system still breathes underground. And scientists are watching carefully because the supervolcano that once darkened the sky is no longer completely quiet. For most people living around Lake Taupo, the earthquakes barely felt important at first. Tiny tremors, a slight shake, maybe a cup rattling on a table for a second. Nothing unusual for New Zealand. The country sits along one of the most tectonically active regions on Earth, so earthquakes are part of daily life there. But scientists watching Taupo weren't just paying attention to how strong the earthquakes were. They were paying attention to where they happened, and how often. That's what started making the volcanic system feel uneasy again. Over recent years, earthquake swarms increased beneath and around the lake basin. Not one giant earthquake, hundreds of smaller ones clustered through the region. That pattern matters in volcanic systems, because swarms often indicate underground movement. Rock fracturing beneath the surface. Basically, the earth reacting to something happening below. Then researchers noticed another problem. Parts of the lake floor itself were deforming. Some areas slowly lifted upward, other regions sank slightly. At first, the movement was subtle, only detectable through GPS measurements, satellite monitoring, and precise geological instruments. But the pattern became increasingly difficult to ignore. The caldera was breathing. That's the strange language volcanologists sometimes use for active supervolcano systems. Because the ground physically rises and falls over time as pressure changes underground. And underneath Taupo, there are several possible causes for that pressure. Magma movement, hot fluids, hydrothermal activity, gas accumulation, or combinations of all of them interacting together deep beneath the lake. The important thing is this: the system is not dormant. It's active enough to deform the landscape in measurable ways. That's why scientists monitor Taupo so intensely, despite the fact no eruption appears imminent. Because supervolcanoes rarely behave dramatically right before activity begins. The warning signs are usually subtle at first. Earthquakes increasing, ground shifting slightly, heat flow changing, gas chemistry fluctuating, tiny clues scattered through the geology. And honestly, one of the creepiest things about Taupo is how ordinary everything above the lake still feels. People go fishing, speedboats cross the water, tourists relax at lakeside hotels, children swim near the shore during summer. Meanwhile, directly beneath the lake floor, the crust of New Zealand may be slowly flexing above a gigantic volcanic system, still carrying enormous heat underground. Scientists studying Taupo often compare the caldera to a giant pressure system hidden below the surface. Most of the time, the pressure changes remain relatively harmless, but the system never truly turns off. That's what makes supervolcanoes different psychologically from ordinary volcanoes. The danger is mostly invisible. There's no smoking mountain constantly reminding people what exists underneath. Lake Taupo looks peaceful, specifically because the volcanic collapse happened long ago. After the ancient eruptions, the caldera filled with water over time, creating the massive lake people see today. Nature covered catastrophe with scenery, but the geology underneath never disappeared. Researchers using seismic imaging discovered that molten or partially molten material likely still exists deep beneath the Taupo volcanic zone. The region remains one of the most volcanically active parts of New Zealand, and Taupo is not isolated. The entire surrounding volcanic zone contains geothermal systems, hot springs, steam vents, and active fault structures showing enormous heat still rising from below. That's another reason scientists became cautious about the recent deformation. Because active geothermal systems can change rapidly when underground pressure shifts. Hydrothermal explosions, steam-driven eruptions. Not every volcanic hazard requires a giant eruption to become dangerous. Sometimes, the Earth simply releases pressure in smaller, violent bursts. And the lake itself complicates everything. Water interacts with magma in unpredictable ways. If magma rises into groundwater or lake systems, the interaction can become explosively violent due to rapid steam expansion. That's one reason underwater volcanic systems are so closely monitored globally. The pressure dynamics become much harder to model precisely. At Taupo, researchers continue tracking earthquake swarms and lake deformation carefully because the system behaves more dynamically than many people realize. And honestly, the silence above the lake almost makes it feel worse. No smoke, no lava, no dramatic warning signs visible to ordinary people. Just blue water covering one of Earth's largest active volcanic systems, a supervolcano that once devastated huge parts of New Zealand and may now be slowly shifting underground again. Scientists are careful when talking about Taupo, and honestly, that caution is important, because the internet loves turning every earthquake swarm into the apocalypse is coming. That's not what researchers are saying. Nobody credible believes a giant supereruption is about to happen tomorrow. In fact, the odds of a civilization-ending eruption in our lifetime remain very low. But low probability does not mean zero risk. And Taupo is dangerous, specifically because even smaller eruptions from this system could still become devastating. That's what people often misunderstand about supervolcanoes. They imagine only two possibilities: nothing happens, or the world ends. Reality is much more complicated. Volcanic systems like Taupo can produce a huge range of events. Hydrothermal explosions, smaller eruptive episodes, ash-producing eruptions, localized lava activity, major regional eruptions, and somewhere, at the far extreme of the scale, sits the truly massive caldera-forming event people associate with supervolcanoes. Scientists monitor the system because they want to understand where the pressure underground is moving along that spectrum. Because modern civilization around Taupo would not handle even a moderate eruption well. The region today is filled with roads, power systems, tourism infrastructure, farms, towns, communication networks, and transportation routes across New Zealand's North Island. Ash alone could become catastrophic. That's one thing people constantly underestimate about volcanoes. Ash is not soft fireplace dust. Volcanic ash is crushed rock and glass particles blasted into the atmosphere. It damages engines, contaminates water, destroys crops, collapses roofs, shuts down airports, disrupts electronics, and spreads incredibly far depending on wind conditions. Even relatively modest eruptions can paralyze huge areas economically. Now imagine a significant eruption from Taupo. Air traffic across parts of New Zealand could halt rapidly. Entire regions might lose power temporarily. Water systems could become contaminated. Agriculture would suffer badly. Emergency evacuations could become chaotic, depending on eruption style and warning time. And honestly, one of the hardest things about volcanic crises is uncertainty. Earthquakes increase, the ground deforms. Scientists issue alerts, but nobody can say exactly what happens next with total confidence. Sometimes systems calm back down. Sometimes magma stalls underground. Sometimes eruptions happen unexpectedly after long, quiet periods. That uncertainty becomes psychologically exhausting for nearby communities. And Taupo carries another layer of fear because of its history. People know what the volcano did before. Even if another giant caldera eruption remains unlikely anytime soon, the knowledge alone changes how scientists approach every sign of unrest, because the system beneath the lake has already proven what it is capable of under the right conditions. That memory never fully disappears in volcanology. Researchers studying Taupo often focus heavily on patterns rather than isolated events. One earthquake swarm alone may not mean much. One deformation episode may remain harmless. But repeated activity over years helps scientists understand how pressure and heat move beneath the caldera. That's why monitoring networks around Taupo remain so extensive. Seismic sensors, GPS stations, gas measurements, lake monitoring systems, satellite imaging. Scientists are essentially listening constantly to the volcano beneath the water, trying to detect changes early enough to understand what the system is doing. And honestly, supervolcanoes are frustrating because they operate on timescales humans struggle to emotionally process. The pressure underground can evolve slowly over centuries, then shift suddenly. Long, quiet periods create false confidence. Civilizations start treating dangerous landscapes as permanent and safe simply because nothing dramatic happened recently. But geology doesn't care about human memory. Taupo's ancient eruption happened long before modern New Zealand existed. Long before modern science, long before anyone could monitor seismic waves or satellite deformation. Today, scientists can track the volcanic system far more accurately than ancient humans ever could. But even with modern technology, major uncertainty remains. Because no scientist on Earth can predict volcanic systems perfectly, especially caldera systems this large. That's what makes Lake Taupo feel so eerie psychologically. Everything above the surface still looks normal. Restaurants remain open along the waterfront. Tourists photograph sunsets over the lake. Boats move quietly across the water. And beneath all of it, deep underground, enormous heat still exists inside the crust of New Zealand. Pressure still shifts. Earthquakes still fracture rock. The lake floor still deforms. And scientists continue watching carefully because the supervolcano beneath Taupo has not gone cold. Not even close. Tonight, Lake Taupo still looks peaceful. The water is calm. Streetlights reflect softly along the shoreline. Tourists